Delphy Labs shoots to startups today. With LLMs and semantic layers in play, he's making self-serve analytics a new pathway. Text-to-SQL may sound like the dream, but without solid pipelines, it's not as it seems. Data engineering's the backbone, tried and true, and David's here to show us why it's essential too, especially for you.
Thank you. Thank you so much. That's so cool.
Welcome, David. Let's go, David.
Yeah.
It's your turn.
For everything. So, like was sung just now, I'm talking about, can we use AI on data? And is it actually just a joke? Is it snake oil? Or can we actually get real value from it? So a bit about who I am first. So right now my role is VP of AI at Cube. What that means is it's roughly a product management role where I look after our AI features that go into our product. I will explain what Cube is later as well. I also write a blog at davidsj.substack.com. Some of you may have seen it, some of you may not, but yep, that's another thing I do. And before I joined Cube, I was a co-founder of a company called Delphy Labs, where I did this very thing. You know, we applied LLMs to semantic layers. And I've been in the data space for roughly 15 years, the last 3 of that in and out of different startups. And I'm from the UK. Don't throw stuff. So briefly what I'm going to cover today is why everyone wants to talk to their data, and they really do. And what's text-to-SQL? What's text-to-semantic layer? And some evidence about which one is better, and I'll come to that later. And then some time for questions and answers of yours. So firstly, what's the problem space? The problem space is that organizations do really want easier access to data. And so one of the things that we did when we founded Delphi was we surveyed some Looker data leads. And Looker at the time was roughly considered the most self-serve friendly BI tool. And what we found was when we asked them what percentage of their organization of data consumers did they feel could easily access data using Looker, they said about 25%. And then of that 25%, only 10% were really, really competent at using it. So, even though that's bigger than what it used to be with, say, Tableau, it's still really, really far off full data democratization. And so along comes AI, and I really mean like the GPT-3 era, post-GPT-3 era, which we're now in. And people really start to think that LLMs can do everything. And that includes writing SQL. And so that brings me to what is text-to-SQL? And what it is using generative AI to make a SQL query based on a given database schema. And this is roughly the architecture of how it works. It's really simple. And so the LLM is provided the database schema as part of the prompt, along with the user's question, which is the part of the prompt that changes each time. And the LLM then generates a SQL query that's run against the user's data warehouse, and the results of this query are provided as the answer. And so why has this become a phenomenon? And now I've called it text-to-SQL, and you may not be familiar with that term, but you will have seen many of these startups come out of the woodwork saying, oh, here's an AI data analyst, right? And why it's a phenomenon is firstly because it's actually quite easy to do, to build this method. There are so many blogs showing how you can build one of these in a Jupyter Notebook in an afternoon. And you can make this kind of application without any retrieval augmented generation. It looks really cool, and it's the same way ChatGPT looks cool. You write something and it talks back to you like Tom Riddle's diary, but it's something unfathomable to most, and that's why it looks like magic. For experienced data analysts, I think it can be really helpful because it can act as a co-pilot to help them generate some code real quick, and then they can fix that code and move forward. And I've tried the Snowflake Copilot, Databricks Genie, which are the versions that they have of this kind of tool, and they're great for this purpose. And I could see myself using that if I was using those platforms today. And the other reason why it's such a phenomenon is how much venture capital has poured into this space. You're talking about, probably in total billions have been poured into this over the last 2 years, maybe tens of billions. And then so with all that money, they've got a lot of potential energy. They're making a lot of noise on LinkedIn, as you've seen. So why is it bad? So the problem with these tools are they've been given your database schema. They don't know about your organization. They don't know about the world that your organization operates in, unless they're provided with some kind of knowledge graph or context to use in prompt engineering. And when it doesn't know your specific business and how it works, what it does is it means it hallucinates. It finds it very hard to come to a good answer easily. And so a lot of these tools always give an answer, and at least give an answer that it thinks is likely to be correct. And so the problem with this is that it's nowhere near good enough for the precision of what you'd need to offer in an enterprise or business context. A stakeholder is not going to trust a tool that is right, 70% of the time. And so non-technical users really can't use them for self-serve analytics. It's not going to meet that demand. And your non-technical users, they don't have the skill to debug the SQL generator and see that there was a slight mistake here and there. And there are many tiny nuances in SQL code that can result in really horrible answers to a question. And so this is like one thing where I wrote a piece about this on my blog. I called it A Darker Truth. And it's something I thought about for a while as to why this solution would never work. And I actually believe even if you had a perfect system, that whenever you asked a question and it generated the right query, it wouldn't be acceptable in business. A perfect system. And I held on to this knowledge when I founded Delphi because I kind of felt like it was a bit of a competitive edge for me. But now that I've joined Cube, I feel happy to share it. And so firstly, the reason why I think that is because it's a black box. Even if it was all-powerful and could generate the right SQL every time, what it's trying to do each time is generate the meaning of your data and then query it in one step every time you ask a query. And that's even if you do put a knowledge graph into the context. It doesn't have to follow that knowledge graph. It can take that as context and do what it wants afterwards. Yes, it will help, but it's still probabilistic. And so this won't work. I don't know if I've worked as a senior analyst before, and I've been that person that sometimes, like a C-suite person, will stick their head out the boardroom door and say, "Hey, David, there's something wrong with these numbers," and I'd slightly wet myself and then go and try and solve the problem. But some of you will have been in that position, and there is no one in this context to take that blame and to be responsible for the answers it gets, because it's a black box. And so, finally, that blame piece, it needs to happen. And stakeholders, in order to use a tool that they're not responsible for and to rely on its answers, they want someone to be accountable for that tool. And they won't accept being accountable for it themselves. Because yes, the tool can be wrong. The tool can give the wrong answer. But if there's no human responsible for it, then the stakeholder takes the blame. They're not going to take that blame, I promise you. They want you to take the blame. So that's kind of the darker aspect of it. So what's the alternative? And so this is where text-to-semantic layer comes in. And so this is, as I said, what I worked on at Delphi, what I work on at Cube now. And I think, given that semantic layers aren't necessarily known by everyone, I'm sure many of you will have heard of them, I think it's probably a good idea to talk about one. So what does a semantic layer do? So they create a single source of truth, a single place to define your metrics and dimensions on your data model. And so they're an abstraction on top of a relational data model that prevent you having to materialize your metrics in fixed-grain MART or OLAP cube type tables. They aggregate data on the fly and based upon the request their APIs. And so this compiles to executable SQL on your data warehouse at the point of request. Semantic layers also make governing and securing your data much easier. It's really hard to secure data when you don't know what it is. If this is table X, and I've known people to name tables with UUIDs, right? You've got UUID table, weird name field. Like, how do you know what that is? Security's answer to that is to say, oh, none of that data is allowed to be accessed because I don't know what it is. Whereas with a semantic layer, you've kind of said this table is a customer, and this field is the customer's email address. It's a PII field. So that gives security much more confidence in being able to secure data for your organization. And so you're giving access to semantic terms, linguistic terms. So these are like nouns, adjectives. That's what a semantic layer has in terms of entities with their attributes and their measures. And these linguistic terms are actually, that's what the body corpus of LLMs are. They've been trained on language. They can write SQL because they've seen some Stack Overflow code which is writing SQL. That's why they know how to write SQL. But the vast majority of what they've been trained on is just language. So you want to stick to language as closely as possible. So a bit about what a semantic layer is further. So this is Cube, where I work. Cube is the only open source and open standard for a semantic layer in existence today. We have 20K GitHub stars. It's the only one where the compiler is open source as well. And our heritage is in embedded analytics. So teams have used Cube to build customer-facing data products. And you've probably been using some of these for years now. And we also have hundreds of paying customers using Cube Cloud. And that really helps them deploy Cube easily. And so what we can do in Cube is express that semantic model. You can express it in YAML, JavaScript, or Python, and with access control defined here as well, so that you can say, okay, I'm defining that this cube is a customer, and I'm defining which roles can have access to that entity, and also down to that attribute or measure level as well. We have a state-of-the-art analytical cache, and we have customer case studies where they've saved, in total, including paying for Cube, more than 50% of a 7- or 8-figure Snowflake or Databricks bill. So back to the question. It's using generative AI to request data from a semantic layer. And I really want to emphasize request, because we aren't relying on an LLM to generate true code here. We're asking to generate a request only. So why is this less common? Firstly, it's hard. That's something that we did as a startup at Delphi, is build this system, and it requires a complex retrieval-augmented generation system to work. Also, semantic layers, even though they've been around in some form since the 90s, so if any of you are familiar with business objects, that was roughly one of the first semantic layers, not exactly what we can do today, but something similar. The term universal semantic layer, which is kind of people have also called headless BI, that's not been around that long, really. So why is it better? So it does know about the world that you have defined as data engineers. You've defined the model code. You've defined how your data model fits together. You've defined which column to aggregate to define revenue. You've defined which column is the ID to count, because that's the entity for a customer. And so text-to-semantic layer relies heavily on retrieval-augmented generation to restrict and enrich its knowledge about your semantic layer. And it's restricted to that semantic layer. If it's asked about something that isn't defined in the semantic layer, it says, I don't know. That's a feature, not a bug for me, because that's what a data analyst does today. If you ask a data analyst about data that they don't have access to or that doesn't exist, they say, sorry, I can't help you, or we need to go and do this data engineering work first before I can answer your question. And that's the right answer. Yeah, and I just covered that. And so loosely, this is the architecture of how it works. And so the LLM is going to request from the semantic layer. And the semantic layer will deterministically generate complex SQL code from that request. And therefore, the LLM only needs to generate a very simple high-level API request, which is really, if you think about what a REST API request is, it's like a blob of JSON, which is like a shopping list of things that you want. Give me these metrics, these dimensions from this place. You know, it's very much closer to language than SQL is. And so it's consistent. What happens is, because you've constrained it to the knowledge that's in the semantic layer, and then you've also constrained it to making an API request and not writing code, it's constrained twice, and it just doesn't make nearly as many mistakes as text-to-SQL. And one of the things that we've seen, and I'll go into a case study where we've actually tested this on a benchmark. And the other thing is it's transparent. It's not perfect, of course, like any system, especially a probabilistic system, it gets things wrong sometimes. But the great thing about it is that because it's taking things from the semantic layer, if it gets something wrong and it chooses the wrong thing, it can show the user, oh, I chose revenue less depreciation, right? And the user can say, no, I actually just wanted net revenue. But if that kind of mistake is okay, it's the kind of mistake that an analyst would make in real life when they're talking to a stakeholder. And because of the transparency about knowing what it chose, it's not disastrous like with text-to-SQL where you don't know what went wrong. So there is a human in the loop with this method, and they're in control of the data. They are accountable for the data model and what it means. And that's why it's acceptable to stakeholders as well. So this is some results. We tested the two methods against each other. So last year, Juan Sequeira, who works at Data.World, released a benchmark which the DBT Labs team replicated. And the benchmark is called A Benchmark to Understand the Role of Knowledge Graphs on a Large Language Model's Accuracy for Question Answering on Enterprise SQL Databases. A bit of a mouthful. But it's kind of a perfect benchmark for this kind of use case. And it's based on a relatively small data set of 11 entities focused on like an insurance context. And so this is not a huge data model. It's of reasonable complexity, but still way less complex than probably what you deal with at work. And so the first three columns show how text-to-SQL is limited even with really great context provided. And the real lift that you see coming close to 100% is when text-to-SQL is introduced. And so we achieved 100% on this benchmark when we used Delphi with Cube, and what we built at Cube today with our AI API and AI system is basically very, very similar to what we have at Delphi. And so the other evidence that we're seeing is people are gradually switching to this method. And so on the right is a post from Ethan Ding, who's a founder and CEO of text-to-SQL. So text-to-SQL started off doing text-to-SQL. I know Ethan, so that's why I'm kind of like shaming him a bit here, but he's fine with it. He's a good guy. So text-to-SQL, they've decided that they've tried this method for a year, which is text-to-SQL, and they've decided to pivot because they don't believe in it anymore. And, you know, they're talking about an ontology which maps business objects to database objects. And, you know, that might sound very familiar to you from what I've been talking about just recently, because it's very, very similar to a semantic layer, if not the same. And the other thing is, and we've been working with Snowflake and Databricks on these things, is they're heading in the same direction. Snowflake have released Semantic YAML to use with their Cortex Analyst product, and Databricks now accepts metrics definitions into Unity Catalog, and so that will include ones from Cube and also ones that you can define there. And from my prediction is, I think by the end of 2025, we'll actually see them take a further step, because right now they're providing that as context into the prompt engineering. They aren't doing the constraint of having an API where the LLM requests from the API and that is compiled in SQL. They haven't taken that step yet. The reason they haven't taken that is because it's hard, and that's what Cube's been doing for 5 years, is building that compiler. But I do think that they'll probably go this way, probably by the end of 2025, that they'll start on this path. So, yeah, no more hallucinations. I think this is the method that can work for self-serve analytics. And one of the things I'm concerned about is if we don't adopt this kind of method and try and do it the easy way, then the shortcut way, is that we'll actually make people believe that it's not possible. And it is possible. I've seen that it's possible. And I really hope that we progress towards this method, partly why I'm giving this talk. And so in conclusion, text-to-SQL, suitable for a copilot, suitable for a skilled data user like yourself, but text-to-SQL is the method that can work for giving self-serve access to non-technical stakeholders. So here's some resources before Q&A that you can have a look at if you like. And so that's my talk. And so open for questions.
Here's David leading AI and keep showing the way.